Welcome to this lecture of numerical analysis. In today's lecture, we will discuss about the numerical integration. The general problem of numerical integration can be stated like this. Given a set of n plus 1 pointers x0, y0, x1, y1 to x and yn of the function y of x, where y of x is not known explicitly, it is required to find the value of the integral from x0 to xn y of x dx. First, let's try to understand what we are given. We have an unknown function y of x which is not given explicitly to us, but we are given it is n pointers from its domain which are x0, x1 up to xn, and we are given the functional values of this y of x at these pointers. So that means what we are given this x0, x1, xn, and we are given that this y of x0 is equal to y0. Similarly, we are given y of x1 is equal to y1, and so on. We are given y of xn is equal to yn. So that means in the interval x0 xn, we are given the functional values of only n plus 1 pointers, and we are required to evaluate the integral over the whole interval x0 xn for this function y of x dx. Now here in this problem of numerical integration, first we will study the trapezoidal rule as how to evaluate an integral where we are given this kind of information, and then second we will discuss about the Simpson's one-third rule. So we are going to study two rules in this video lecture. The first one is a trapezoidal rule. Given a set x0, y0, x1, y1 up to x and yn of n plus 1 pointers, the integral from x0 to x y of x0 to xn is actually here. So this is x0 to xn y dx. According to trapezoidal rule, this integral is defined as h by 2, then bracket y0 plus 2 times y1 plus y2 plus yn minus 1 plus yn, where h is the minimum of modulus of xi minus minus 1. So first let's try to understand how do we define this integral, and what is this h, and how do we define this h. So in fact we are given these n pointers over the interval. We are given the interval x0 xn. Then this interval is partitioned into n intervals like this. The first point is x0 to x1. Then we can combine this interval with x1 to x2, then union, so on, union xn minus 1 to xn. So actually we are dividing, we have this x0, x1, xn, these n plus 1 points will divide this interval x0 to xn into n distinct intervals. Now the length of the first interval here is x1 minus x0, then the length of second interval is x2 minus x1, and the length of the nth interval is xn minus 1. We will find out the lengths of all these intervals. Like for the first one, it is x1 minus x0 is its length. The second one has the length x2 minus x1, and the nth interval has the length xn minus 1. Then the smallest values of these x1 minus x0, x2 minus x1, xn minus 1, then the smallest value obtained from these n lengths is denoted by h. So this is how do we take our trapezoidal rule into consideration. Now the second rule is Simpson's one-third rule. Again, in Simpson's one-third rule, we are given a set of n pointers which are named as x0, y0, x1, y1 to x and yn of n plus 1 pointers. Then in this case, the integral from x0 to x y x dx is defined as h by 3 y0 plus 4 times y1 plus y3 plus up to yn minus 1 plus 2 times y2 plus y4 plus so on up to yn minus 2 plus yn, where again h is defined as a minimum of xi minus 1 as we have defined h in trapezoidal rule. So these are two rules. One is trapezoidal rule and another is Simpson's one-third rule. Why this is called Simpson's one-third rule? Actually we are using the number h by 3 here. So because of this 1 by 3 as a coefficient of this product or sum, we call this rule as the Simpson's one-third rule. Okay, now let's move towards the example. We are required to evaluate the integral from 0.1 to 0.5 y of x dx, where we are given that at x equal to 0.1, y of x takes the value 0.09983, at 0.2 it takes the value 0.19866, and similarly at 0.3 this is the value at 0.4 is given, and the value at 0.5 is given. So first let's name these points so that we can easily use them in trapezoidal rule as well as Simpson's rule. So this is our x0, and this is our value for y0. This is our x1, this is the corresponding value for y1, this is x2, this is the value for y2, and then we have x3 as 0.4 and y3 as this value, x4 0.5 and y4 is 0.47942. Now let's move towards the solution. Given y0 equal to this, y1 equal to this, y2, y3 and y4, we have named these four functional values as y0 to 5 functional values as y0 to y4. Now according to trapezoidal rule, integral from x0 to x4 y dx, this is defined as h by 2 into y0, as we have defined in trapezoidal rule above, h by 2 into y0 plus 2 times y1 plus y2 plus y3 plus y4, where h is equal to 0.2 minus 0.1, which is 0.1. Actually, why we have defined h as the difference of these first 2 points only? Here actually this 0.1, 0.2, 0.3, 0.4, 0.5, they are equally spaced. If we take the difference 0.3 minus 0.2, we again get 0.1. 0.4 minus 0.3, it's again 0.1. 0.5 minus 0.4, it's again 0.1. So therefore the minimum of xi minus 1 is 0.1, which we call h here. So now just we need to substitute the values. Now x0 is 0.1, it is substituted here. Then xn is, that is x4, that is 0.5, y dx, this is equal to h by 2, so h is 0.1 by 2. Then y0, the value for y0 is this one, so this is our value for y0. This is the value for y1, which was given. This is given value of y2, this is given value of y3, this is given value of y4. Then adding this y1 plus y2 plus y3, we get 0.88359 multiplied by 2. Then y4 is at its position 0.47942, and y0 is again repeated here 0.09983. Then adding these quantities in the bracket, then multiplied by 0.1 by 2, and finally we arrive at the answer, which is 0.1173215, which is the required value of the integral from 0.1 to 0.5 for this function y dx. Okay. Now again we do the same question using the Simpson's 1/3 rule. By the formula of Simpson's 1/3 rule, we have x0 x4 y dx. It is h by 3 into y0 plus 4 times. Okay, so let me first repeat the Simpson's 1/3 rule here. It was defined like this. It was h by 3, then we have y0 here, then plus 4 times y1 plus y3 plus so on, plus up to yn minus 1, then plus we write 2 times y2 plus y4 plus so on up to yn minus 2, and then finally we add yn and close the bracket. So now using n equal to 4 here, so we have x0 to x4 here, h by 3 same as h by 3, and then we have y0 same as y0, then y1 plus y3, because yn minus 1, n is equal to 4 here in this case, so we get y1 plus y3 into 4, then plus 2 times y2, because 4 minus 2 is 2, so we have only one term here, plus y4. So this is how we substitute the values in this Simpson's 1/3 rule. Now we just need to evaluate the values. y0 is 0.09983, substitute the value for y1 and y3. So here we have, this is our y0 which was given, this is y1 which was given, this is y3, this is y2, and this is y4. Now using the calculator we can take the sum of all these numbers inside the bracket, which happens to be equal to 3.52257, then multiply it with 0.1 divided by 3, that is equal to 0.11749. Now we can compare the two values. Now according to trapezoidal rule, we obtained the integral as 0.1173215, and we obtained the same integral as 0.117419 using the Simpson's 1/3 rule. So that's all about today. Thank you so much.